Particular class is really designed for the educators that might be joining us. Some of you, most of you, I believe, actually own this machine. If you don't, then let's just do a quick run through. So this, as it's named, is the Bantam Tools desktop PCB milling machine. This came out in a sort of different version about 5 years ago, and the real intended purpose was kind of two things. One, to make prototyping much easier for electrical engineers, so you could make prototyping fast. And mostly like design iterations really accessible. The other piece is that this is a very accessible machine, not just in terms of the software, which we're going to get into in a minute, but it's super portable, right? It's 17 pounds. And so that was the other thing, was how do we create a CNC that is not something that requires a forklift to set up and lots of red tape and things like that. So that's sort of the origin of where this machine is coming from. And today we're going to do two things. We're going to keep this super basic. It's CNC basics, so we're not going to get into full 3D operations. We're going to do first up we're going to sort of walk through how to make a breakout board and take you through all the steps for doing that. And then we're going to get into 2.5D milling. Let's do some quick show and tell, just in case you drop off.
Yeah,
so,
absolutely.
What to even start with?
Well, I've got some thread milling that's up right now. This is one of my favorite ones where we did it, where you can see it's actually cutting some metal. This is a little more advanced thing. We're going to get into this a little bit later today.
Jumping right to the super advanced stuff.
Just the metal in general. I'm not going to get into the thread milling. That was the whole thing.
Yeah.
And a learning experience for sure.
But this machine, I would say it's also kind of like, you can think about it as kind of like the gateway CNC, because you can do, I'll put some of these underneath this camera. Pete, let me know if this is good.
Yeah.
So high, sort of really fine detail engraving work is very easy to do. If you're etching into acrylic and want to do some edge lighting, it's really fun and very simple to do. If you want to get into some more complex things, like how do you take tool paths and do sort of create gouache, or these kind of like fun, mesmerizing optical illusions just based on tool paths, or maybe it's something more complicated like milling a topographic map. One of our remote residents is really good at this. So it's very capable for lots of things. And then there's also just like some really simple stuff, right? Like making a spirograph by going to like geargenerator.com and downloading it and flying it into the software, and how do you create something that, I think we milled this out in probably about, I don't know, less than 10 minutes.
Oh yeah, it wasn't long.
And so just really quick way to dive into CNC. So I think that's it for the show and tell. Definitely check out our Instagram page if you want to just see sort of like the range of capabilities, but let's dive into milling a PCB. So we've got the machine itself on the table today. We also have some tools. If you're a teacher, you already know like these tools that you're going to be using every time you're operating the mill. Definitely a pair of calipers. This is some Mitutoyo calipers. These are a little bit nicer. We sell some more affordable options in our store as well. Very important for accurately measuring material sizes and thicknesses. A scraper. We'll use this to actually remove some of the stock from the spoil board today. A pair of scissors. And our fixturing is going to be very basic today. So the way in which we're actually going to hold material onto the spoil board, we're just going to rely on this Nidotape, this high-strength Permacell Nidotape. So if you launch the Bantam Tools milling machine software, you'll see that there is sort of a bunch of buttons on the right-hand side to actually set up your job, but then up top, where Pete actually had the mouse just a second ago, you can manipulate the view. So the nice thing about this software is it's not just kind of like inputting your design and throwing it over the fence and hoping that it works. We'll actually visualize the material in the machine, the tool paths, and then also sort of 3D view, so we can actually manipulate around the stock as well. A very easy way to get started using the software is actually just to use the panel on the right, top to bottom. So what we're going to do, we're going to mill this breakout board today. We're going to first start with inserting a tool. There are a bunch of different flavors of end mills. Today we're just going to be using an engraving bit and 2 different flat end mill sizes. So let me just carefully remove that. These are sharp, so be careful. And I've picked these 2 tools, this 1/32 flat end mill and this engraving bit. Let me just put that down for a second. for the board design that we've done in Eagle, and that will make sense in a moment when we get to it. So first we're going to click that upper right hand button for change tool, and the machine, let me move this camera in. The spindle has moved to the center there. It's asking me select and insert a tool. From that new tool drop down, you'll see the 5 thou is actually already selected, but the other options are in there as well. And I'm going to insert this end mill and just kind of hand tighten first the wrench set. All right, and now we're gonna continue with this little modal here. We've selected the right end mill. And now the cool thing about this, the way that this is actually gonna work is it's gonna drive across to sort of a known fixed location. It's always gonna default to this location. There's nothing in the machine at this point, but say we had a piece of material already in here, you can use that XY jog on the left-hand side of the screen there to actually move around where it's actually going to probe. So then we can go ahead and locate that tool. And I'll just sort of explain this as it's going. So the way that this is actually one of the nice features about this machine in particular. It's going to actually make an electrical connection with the spoil board. And when it does that, it's going to be able to know what the height of that tool is, the distance between the bottom of that tool and the top of the spoil board. So, when we first actually turned on the machine, and you know how to do this because you've read the prerequisites, is the machine will home itself. It's going to jog back, it's going to hit one of the limit switches on the Y carriage, the X and Z carriage is going to jog over, hit one of the limit switches over here, and it's going to do the same thing in the Z, but then it still needs to know, well, what's the length of the tool. And so that auto tool probe feature that we have that uses that electrical connection is really handy, and it allows for sort of like just a lot of reliability and a lot of precision. Cool. So we've got our tool in, we're going to go down. We're not doing any fixturing. In future classes, we're going to do some more advanced fixturing. We're going to do some double-sided PCBs. We're going to talk about using the T-slot bed and the toe clamp setup, but for now we're just going super basic. So we're going to skip over that fixturing. Jump into the materials. We know that we're using a single-sided piece of FR1, clicking that down. And now I need to tell the machine what size material I'm actually using. So let me break out my calipers here, turn this on. And even though, if you're using these boards all the time, there is a little bit of variance. So if you want to be absolutely sure, it's a good trick to always measure the thickness. So this one is actually 0.061 for the thickness. I know that this is a 4x5, and I'm not so concerned. It's not really an important dimension for me for this procedure, but if you did have a piece of material that you absolutely want to be sure that you had critical dimensions on the X and the Y, then you can enter those in as well. We're just going to keep 5 inches by 4 inches at 0.061.
The old adage, measure twice, cut once, really does hold true in CNC. Probably measure 3 times, cut once is the goal.
Especially in the Z. And then we're going to jump down to placement. There's another drop down. And so what this is actually looking at is where is that material in the bed? We've already said the dimensions of that material, and the software is visualizing that for us. Now I could be inserting this to the left or to the right or to the back, and most importantly, the Z. So the Z is really being affected here because I have this double-sided tape on the bottom of the board. I know that we use 6 thou as the thickness for that tape. If you're using different tape or using really any tape, you should measure it yourself first. So this is a little bit tarnished now, but this breakout board is a 64-pin QFN package. Should I hold it up here? Oh, down here. This has, these traces, I'm not sure if they're even coming through in the camera, are 6 mil trace and space, sort of trace thickness and the width between the traces. For something like this, you definitely want to make sure that the PCB is really fixed down, because the detail and the resolution that you're going to get with the traces is really going to be dependent on how rigid that piece of FR1 is to the actual spoil board. Okay. Cool, so now let's actually put this in there. Now one thing that I like to use is, Pete's already hit the loading button, which will jog the spoil board forward. You can hit that Y plus button a few times, and the machine will actually bottom out to the backside of this front piece of HDPE. And the reason that I like to do that is because I can just, again, for simple PCBs, I can take my left hand and sort of align it to the left side of this spoil board, and then I can move it all the way to the front touching that HDPE. And that gives pretty decent alignment, certainly when I'm milling a small breakout board within a big, 4 by 5 inch piece. Just kind of press down. Okay, cool, so that's in there. Now we've got the placement, we've got our material width, we've already installed it. Now we're gonna go ahead and open the file. So quick note on working with electronics. So the Bantam Tools milling machine software will really work with any electronics CAD design software that you're using, whether that's KiCad or Eagle, in that it will accept any Gerber file. With Eagle in particular, you can just drag in that .brd file, so anything from the board layout view, straight into our software, and it will pull in all of the respective Gerbers, so the traces, the holes, the outline cutout. So it's really easy, and it's really kind of made for that integration with Eagle. We pulled in our file. Now we're going to actually select the tools. I see that we have the 1/32 flat end mill. Now that's the default tool. I actually added my own tool in the software. So if you hit that drop down, there should be 1/32 for FR1 at the bottom. Now in our software, you can look at our support pages for this, but there's actually a way to go into the tool library and adjust the speeds and feeds that you have for the tools that will appear in those drop downs. So I've gone ahead and just sort of ramped up the feed rate. This is going to move at 59 inches a minute. It's going to plunge at 10 inches a minute. It's going to use a 20,000 RPM spindle speed, so on and so forth. You can see these numbers on the screen. I don't need to read them. But you get the idea. If you want to adjust the speeds and feeds for certain tools, you can do that. As Pete was calling out, there's some red lines in there, and that is saying, hey, I can mill the outline of the board, I can cut out the holes for this board fine, but I'm gonna have trouble actually milling between the holes and between some of the pads. So we need a smaller tool. Before I was saying, I'm gonna tell you why I'm using this 5 thou engraving bit, and this is why. I knew that I designed this board knowing that I would need a 5 thou engraving bit. And this is something that's useful, if you want to teach a class and make sure that the mill time is really, quick and efficient for the class time that you have. Keep that in mind. A board design that's going to be 6 mil trace in space, you're going to need a 3 thou engraving bit, and the mill time is going to be a lot longer. If there were any errors at this point, let's say that there were more of those red lines, or say if you're doing something more advanced, like your G code or the CAM is actually going to crash the machine, you'll see that right below this start milling. There will be something in red that says, hey, you've got an issue, you probably want to address this before you start milling. All
right, so we've done our tool touch off, we've loaded we've entered our numbers, and we've loaded our file. So let's give it a go.
Cool.
And now,
can you still see this?
I'll kick it over the software. There we go.
And so one of the things that's nice too with this software, hopefully you can still hear me over the mill, is there's a real-time feedback between where the spindle is in the machine itself and what it's illustrating in the software. So say you're doing a really long mill job and you're not sure, or you can't see what's going on inside the machine because maybe you're using our dust collection system and you can't actually see the tool, you can rely on the software to have a sense of where am I in this operation. So this part is going to be pretty quick. It's just going to mill out those areas in red that we had before, so really just between the traces, and then it should pause and we'll change the tool. Okay, so next tool, the 1/32 for FR1. I've got that here. I'm going to go ahead and load that in.
Okay, and I'll try and get you a little better view so you can see this. So you see Zach, he's loading it up in there right now. He's doing it by hand. It just slides up in there, and he's hand tightening right now. We just use those wrenches to just kind of get that last little bit in there. He's left a little bit of a stick out in there, which is fine for these 1/32 and what we're doing. You don't want to try, and what I mean by stick out is how far out the tool comes down. You don't want to jam it all the way up in there because it can cause some damage to the end mill itself, or to the collet rather.
I'm going to adjust that though.
And so I think what Zach's doing is he's going all the way up and then just slowly pulling out just a little bit beyond all the way in.
Yep. Okay, cool. And do you want to just say something about what that actually does to the rigidity of the tool?
Yeah.
Right, like if you have a lot of stick out, right, it's not a big deal in this like PCB milling applications, but if you have a lot of stick out, you're going to actually get some deflection. Like if you're milling something in metal that's you know, a lot more, it's gonna load a lot more on that tool, then if you have a lot of stick out, that tool is actually gonna bend back and forth and you're gonna get a lot of deflection. So it's really more important in those applications, but.
Yeah.
Okay, cool, tools in, so now we're gonna probe again, hit that continue.
So head back over to the software here. Yes, we've loaded 1/32 for run ends in, tell it to continue. It's gonna go find a clear spot in the spoil board. We already set it up earlier, so we don't need to adjust it again. Looks good, right, Zach?
Yep, looks good.
Okay.
When the mill actually pauses for those operations, it's only going to pause to ask you to load that tool. You won't actually have to go back in and start the operation again. Some people get sort of confused when the mill starts back up after you've loaded that tool. That's meant to happen. And one important note, again, for the educators that are watching and have probably picked up on this, so the mill doesn't actually operate in its default form with the windows removed. We've rigged this up so you can actually get a better view today, but rest assured if you actually remove any of the windows, your machines will shut off automatically. So it's just finished milling the traces, and now it's gonna mill the holes. Again, it's pulled in all of the Gerber files from that Eagle board file that we sent it. So now it's milling those 8 holes, and then it will go ahead and mill the outline when we're done. Cool, so this board is done. And then I'm just gonna use some alcohol to dissolve some of the adhesive on that tape. And I'll put some over here. And the easy thing to do is just to let this sit for live viewing purposes, to not actually, what's the reverse of watching paint dry? I don't know, watching paint glue dissolve. We're just gonna be quick about this, but, and that's that. So once you get familiar with this, let me move this down, there's our board. Once you get familiar with this setup, you can be really quick with it. And one thing that I didn't point out that we're gonna touch on in a minute is in the software right next to the open files section, you'll see the name of the board and there's that little sort of circular arrow. The way that I like to use our software is I'll have Eagle open in one window and I'll have the milling machine software open in the other. So Andrew, this is like, to answer your question, one thing that I'll do is update some of the trace widths, see how, and then save it, and then refresh in the Bantam Tools software and see how that's affected the mill operation. You know, are those red lines gone now, not by switching out the tool, but just by me changing the trace width? Or, you know, if you really want to get, you know, nerding out about the sort of Eagle setup files, we actually offer, I'm going to blank on the name of it, we offer the Eagle ERC and DRC files that you can use for different tools. So you can just load those into Eagle, and then you can, Eagle will tell you, hey, you're gonna have an issue with this tool on the Bantam Tools mill. So anyway, I kind of keep both of the software applications open at the same time, and then I see how the Eagle file is affecting the mill job. So that's kind of 101 on milling PCBs. Obviously, you can see this is something that was like slightly more complicated. Again, here's the 6 mil trace and space board. This is actually double-sided PCB. So more to come on that. We'll do a follow-on class after this. That's more like intermediate level stuff. So I'm going to go ahead and remove this piece of FR1, and we'll jump into part 2 of this CNC Basics.
And while he's doing that, I'm going to read a question out here to you because we got a couple just now. First off, Chris Wool was wondering if we should put a sacrificial surface underneath our material for cutouts to prevent undue harm to the spoil plate. That's a great question and that's a good instinct, but the spoil plate, that's what it's there for. That is your sacrificial material. That's actually something that you can, you can face it using a flat end mill and resurface it as needed. It's designed to be ground down. It's designed to take tool marks, the tool digging into it. I've accidentally modified my spoil board more than once by missing a decimal place and things like that. So I mean, it's what it's there for. It's part of the thrill of milling.
Yeah. Yeah, actually yesterday, you'll maybe see some green material in here. Yesterday we were milling something in HDPE for a call with some friends, and you know, we actually removed the spoil board for that call, and before today's video live stream, we reinstalled the spoil board. And so to make sure that it was actually very accurate in terms of its Z and consistent, we refaced this spoil board with an 1/8 inch flat end mill. And you can grab that file from our website if you need to do so, or if Pete said you accidentally customize your spoil board through something. So yeah, don't be afraid to mill into it. We actually sell extras. It's what it's there for. All right, so we're going to jump into SVGs and working with SVGs. And again, this is sort of our thinking is that in a classroom setting, and really anyone who's first getting, you know, sort of who's new to this machine should really start out with 2.5D milling. So 3D milling, topo map, right? There's X, Y, and Z features here. The machine is a true three-axis machine. It moves simultaneously. It can move all 3 axes simultaneously. 2.5D milling, right? Something that has 2D features. What's the 0.5? I'm forgetting what the 0.5. What is the etymology of the 0.5?
Well, it's not quite. You're making a 3D thing out of
sure,
2D thing.
2D cutouts. There you go.
It's halfway 3D.
It's halfway 3D, but still, nevertheless, cool stuff. And the project for the second half of this is actually making a 3D puzzle with sort of 2D cutouts. Let's dive in. Actually, and even before we do that, we want to talk about some SVG basics.
Yeah, absolutely.
So we're gonna throw up some slides really quick. I'm gonna keep myself honest. So there's a lot to this, but I put together about 6 tips here. The first one is really, again, use that refresh button. That's your friend. So with SVGs, you're probably gonna be creating these either in Inkscape, free open source tool, or if you have access to Illustrator or some other design program that's going to allow you to create vector graphics, that is key, using that refresh button. And actually basics, SVG, scalable vector graphics. So a raster image, a JPEG, a PNG, right? That's going to look at actual pixel by pixel information. So as you expand that, it's going to get very blurry.
Actually, we've kind of demonstrated that here when we zoomed in our software. You can see how that's getting pixelized. Those are pixels.
Pete calling out my crummy slide.
No, it's great.
Yeah.
But those, so you can see in the little refresh button that we've enlarged for the graphic, you can actually see some of that pixelization. It's like an ice cube tray of colors.
Totally.
So it's a bunch of little squares that are all filled in.
Right.
That makes for good pictures, but not necessarily the best vectors.
Sure. So with a vector, with a SVG, it's actually going to look at lines and strokes. And the reason that that's important is that then we can expand those images dynamically, and our software can read them. It can read those clean lines and interpret them as either cuts or engraving files. So the second tip here, to segue, is that as a rule of thumb, the Bantam Tools machine, it interprets strokes as cuts and fills as engraving. So any stroke file that you have in the outline of, say, let's just say a circle in Illustrator, it's going to see that outer stroke as something that it should, by default, cut out. Anything that had a fill, say you had a black circle within a sort of, nested within that circle, we're imagining lots of things here. Maybe we should just go to the third tip. This will help illustrate it. That inner fill would be interpreted as an engraving. So you can use that to your advantage. So in order to create a cutout within a cutout, I'm going to jump over here underneath this again. Yep. So this was cut out of a piece of Delrin. So in order to create a cutout, the outer sort of rooster, and then another cutout, the eye of the rooster, that eye needs to be actually a fill in the in your design software. So I think that's what we're illustrating on this slide. So tip number 4, my favorite thing, the thing that I first tried to do when I got this machine was use photography as my sort of initial creative jumping off point. So take a photo and then create outlines from that photo and then try and use those as engraving paths. Pete's actually done this a lot, and you could look at our Instagram feed. There's a bunch of videos of us doing this. One thing to keep in mind if you want to go this route, and it's a fun project, is black and white, high contrast images work best. Those will allow Illustrator or Inkscape to actually be able to create those path outlines. And you'll need to tweak the thresholding and the noise values, but something to play around with there. One reminder, if you're doing text, you have to create outlines for text to appear. So on this breakout board, sometimes when I'll do breakout boards, I'll include text with them just as separate SVG files. So you have to remember to create outlines for that text when you're going to fly them in or export them as an SVG. If they're not created as an outline and you save that file as an SVG, the text won't render. It won't know how to render that text. And then lastly, just if you're having issues with our machine with SVGs, make sure that you're saving that SVG as a 1.1 or a 1.0. Those are the sort of SVG formats that play nice with our software. All right, jumping back over to the mill.
Yeah, let's do it.
Cool. So let's go ahead and let's clear out the file.
Mm-hmm. So I'm going to jump over here to the software, and it's pretty self-explanatory. So under the open files section, I'm just going to go ahead and close out the file we just had in there.
And let's start again from where we did before. We're going to change that 1/32 tool. And we're going to use... What are we changing
it to right now?
Today we're going to, or for this, we're going to use a 1/16 flat end mill, and it should be the 1/16 for Delrin that we have in there.
And once again, I put up a little image so you guys can kind of see what's happening in the mill as well when we do this.
Oh, we got ball end mill in there.
See, lots of options. This is why you measure twice, double check your work.
There we go,
1/16 for Delrin.
Yep. Cool.
And I'm going to adjust this up so you guys can see just a little bit better once again on this tool change.
I'm going to go ahead and remove that window so I don't...
just remove it now preemptively? Okay.
Preemptively before I...
There we go. You'll get pretty proficient with this. Lefty loosey, righty tighty.
And again, we're using one of the custom tools here. So on our website, if you go to, again, I think it's homepage, accessories, end mills and bits, and then scroll down, you'll be able to download all of the tool libraries. And then we also have speeds and feeds info on our site as well. I think it's also on that tooling page. And so you can see some of the basic speeds and feeds and the advanced speeds and feeds that we've tested, and they're good starting points for you to use as well. Again, I'm just going to give you the Z here because I know that that's the most critical.
So what's our width here?
4x5, and the Z is 0.128. Let me just measure one other piece. Now with the Delrin, what's interesting is this will actually swell with humidity, which may not be an issue, but if you're creating a puzzle where all these pieces actually have to fit together, it changes how the pieces actually interlock if they're just friction fits. So we'll see. Hopefully this still works. 0.128. It's spectral 0.125. So we'll see. Fun of live demos. Cool. So you've got that in there. I'm going to go ahead and place that in the same fashion. Can you hit the loading button and then jog it forward again? And I'll use the front of the machine. If you hit that Y twice, back in on the machine. Great. And then I'll just reach in here.
Push it down just a little bit because I want to see that edge of the machine. So what Zach was talking about is we've pushed this bed all the way up and we're utilizing the front of the machine there. Yeah,
this is basically like our Y stop. And my X stop really is just along the bed. Now, admittedly, this sort of material placement here, I'm not too concerned about how accurate I am with it being completely zeroed out in the X, because if we open this file, you'll be able to tell we can jog this file around within this material. So we've got the material in. Now let's just go ahead and we'll open this file, and this should be Rooster Puzzle.
And then while I'm pulling that up, Don was asking if stroke width matters for cutouts as well.
Yes.
Is that something we're going to be able to address here?
Yes, it will be. Okay. So let's jog this into place, and then let's talk about some of the advanced sort of SVG stuff. So the placement here, if you click that drop down, it's X0, Y0, Z0. I'm looking at this and going, maybe, just for safety's sake, I want to move that whole design over to the right. I want to go X positive with that. So maybe Pete, can you go over like 50 thou or something, or even half an inch? Yeah, great. And then maybe let's do the same thing on the Y and just set it back from the edge. I would like the rooster nose to come out, and it's whatever that part of the rooster is down there.
So just a little extra slop.
Just a little extra slop. Now, if we go down to placement, parts, engraving depth, keep scrolling down below the tools. Let's go ahead and just select the right tool first. So we need to put in that 1/32 or 1/16, excuse me, for Delrin, and then clear out the other tool. We're not going to use that.
And for today, we've optimized this job just to use one tool, just so we can kind of go through it. But oftentimes, we'll be using multiple tools, and you can load them up here. The software is smart enough to figure out which ones it should use in which situations for SVGs.
Right. Okay. So now scroll down below that, and let's look at some of these advanced setups. So first off, we'll notice if you can make that viewable too. Okay, great. So before we were talking about cutouts within cutouts, so let's address that first. So the way that you can see the eye of the rooster, there's something that's happening there. We see the toolpath, but it's not going all the way through. And the reason that it's not going all the way through is that the machine, as we said, has read that inner fill as an engraving operation, but the engraving depth that we have set is only 6th thou. And we need it to be the thickness of the material in order for it to actually use that engraving sort of feature as our internal cutout. So we're going to set the engraving depth to whatever our material thickness was, which I believe was 0.128.
I'm going to scroll up and just double check that's what we put in there today, because we've been doing a lot of Delrin. So 0.128 in the thickness.
0.128.
And we just tab out of there or click off of there and it'll update.
And now we can see that full eye is being milled out. So now we've taken care of that. All right, we've got a couple questions about the stroke width thing, and look at this sort of advanced tab below there. So right now, and even Pete, before we even go to there, can you toggle the engraving and the cutout so people can see that?
Absolutely.
So if we toggle off the cutout, we'll see just the eye. If we toggle on the engraving now, and just the cutout, obviously the inverse. So it's reading those correctly. Now if we put them both on, and we go down to that advanced. So it's saying we are not inverting this image. If we want to invert it, what we would do is actually cut out within the stroke. And so that's that no. If we flip that on and off, we can just visualize that really quickly. If we said yes within cutout, this might render for a second. Okay, so now it's actually cutting out everything. So we're getting the inverse of what we actually want. The milling time went way up because we're using this small tool to remove a bunch of material. So that's not what we want. We're going to take off of that. Oh, you want to show all the options?
Why not?
Okay. And then the other ones, just to move this along a little bit, scale from document contents and document bounds. So if you have a bunch of SVGs and you're doing something that's really complex, what you want to do, and you want to align, like I was saying, if you want to do more than just a cutout within a cutout, let's say you have like a cutout within a cutout within a cutout, you're going to have multiple files. And how are you going to align all those files? So the trick for that is to actually set up your artboard in Illustrator or in Inkscape to be the exact dimension of the material dimension that you feed our software. And then instead of scale from document contents, you'd say scale from document bounds. And every new file that you open up, as long as you select that, will automatically place that SVG in the proper orientation that you're seeing in Illustrator. So that's what that's about. Now, the stroke width thing. Okay, so if we change the stroke width in Illustrator, the feathers within that rooster, let's say we made a thicker stroke width, this space between them would obviously be thinner. If we made a thinner stroke width, then the space between those feathers would come across as being wider. So when I was actually adjusting this, when I discovered that Delrin swells with humidity and the poor rooster was having trouble staying together, I actually used the stroke width to make those micro adjustments and then hit refresh in the software and ran a couple more jobs. So that does plan. All right, let's get this rolling.
So yeah, here we go.
Marked areas need a smaller tool, and the reason that it's saying that for this is because we're using that engraving trick.
So yeah, everything in red it's not doing. So,
right.
Which is good. All right.
The first thing that it should do is mill that eye, and so long as, I forget whose question that was, so long as our Z was right, we shouldn't be customizing our spoil board. If our Z was off, then we might mill into that spoil board a little bit. hopefully we have enough leeway just with the tape that's on there. And now, again, we're driving this, this 1/16 little end mill. We're going to be using it a little bit faster than some of our default settings, just for the sake of this class. So and Delrin also does some weird things with where it electrostatically sort of binds, or not binds, but it sticks to all the chips, kind of stick to itself. So when we pull this off, it's possible that it's going to be a little bit furry. We can clean it up, and also if you wanted to make sure that you are getting absolute sort of clean edges, you can go a little bit slower. But rather than have you sit through something that is maybe 15 minutes, I just wanted to speed this up.
Now might actually be a good time, and I'm going to talk to you maybe about milling metals and some tips there, because once you get plastics figured out, so maybe you want to move on to something a little more robust.
Yes, totally. So,
and I've got some more of those metal videos up while we talk.
Okay, cool. So I think the first thing to keep in mind if you're going to switch over to milling metals is, starting out with just some basic sort of geometry, figure out how to just clear sort of a channel of material, or maybe you're milling what's called the pocket. You're going to mill just a circular feature. The thing is just, it's obviously metals are going to be harder than some of the plastics. They're going to be more dense. That question about tool life and accurately measuring the Z height of the tool is going to become more important, because the chance that you might break a tool goes up if you're off with some of those things. But again, if you're using our machine, use some of the default speeds and feeds that we have provided as a rough sort of basis for what it is that you're doing, and then go from there. So simple geometries. There's so many YouTube videos out there. If you're going to get into metal, you're probably going to, at that point, be getting into Fusion 360 and some more in-depth CAD and CAM. If you're just using our software, the CAM is intentionally sort of simplified, and we're taking care of some of those toolpath questions for you. If you're getting into something, here's a little, if anyone knows Titans of CNC, they have these little building blocks.
I actually got that video up right now. I'm showing some of the stuff, and so we're going to be able to see it that way. Probably a little better shot, hopefully.
Oh, awesome. Milling sort of, pockets and adaptive clearing strategies and contours. As you get into some of that, YouTube is going to be your friend, and we'll have a follow-on class. One thing that we have a lot of fun with is, how do you use toolpaths? Can they see this camera?
Yeah, here we go.
How do you use toolpaths as sort of a decorative feature? So here's us just taking a flat end mill and doing sort of a flower pattern to create this kind of gouache pattern. We talked about engraving in metals. This is another good way to just get started, getting your feet wet using a metal engraving bit as opposed to a PCB engraving bit.
What's the difference between the two?
Well, the PCB engraving bit is really designed for the PCB applications. The metal engraving bit, it's going to be a lot more robust if you look at those tools, so it's going to be able to handle the operations of engraving a metal. This knurling pattern, I believe we did with a metal engraving bit. This is a piece of brass. And then the last point that I would say, just as metal basics tips, and again, we're going to have another follow-on video that's a lot more advanced, is not all metals and alloys are equal. So here's a piece of aluminum 6061. This is a piece of aluminum 7075. They're different alloys altogether. The 7075 is actually more dense and has a rates higher on the hardness scale, but weighs less. The aluminum 6061 is a little bit heavier, but it's easier to machine. And this is sort of the bread and butter of a lot of CNC machine shops. But definitely know what it is that you're cutting. We sell brass. This is a brass 360, which means that it actually has a little bit of lead in it to make the machining easier. So know your alloy, and then like anything starting out with a project, like I'm a big everyday carry fan, and here's a little sort of I don't even forget what. What is the name of this thing actually?
It's a knotting tool.
It's a knotting tool, thank you. Here I'm saying everyday carry fan, I can't remember the knotting tool. But anyway, this was just like a nice way to take some of the fusion basics that we knew at the time, boring, contouring, adaptive clearing, decorative sort of facing, using a radial pattern to pull it together for a project. So
Oh, look at that. Looks like that just popped right out. I think we nailed our depths.
We nailed our depths. It's a little bit fuzzy because I doused everything in alcohol first. I probably should have blown that off before I did that, but yeah. This is actually, Pete, do you want to...
Try and assemble this? Absolutely.
You could clean it up while I just wrap up the skill score portion of this. Here's a leg.
Thank you.
Leg, this. Here's this if we need to get some fuzzies off. So that's pretty much what we had in store for you. You know, for people who want to, what's that?
There's a brush. Do you have that too?
Yeah, there's a brush.
Thank you.
There you go.
A handy brush. We sell them in the store.
So the idea for this skill school class is that, you know, certainly for people who just got the machine and want to work through some of these projects and make them their own. Danny, it sounds like you're already doing that. We're going to upload all the files to that skill school page after this. If you're a teacher, look out for the forking or cloning the class function that should be live within the next month. And you'll be able to, again, take this class if you have some other prerequisites that are good for your school or high school. You can build those in and just sort of use this as the jumping off point. And then we're going to be doing some more intermediate classes and advanced classes and really trying to give back and share what we've been learning. I think the point that I didn't mention in the beginning is, like, I have a little bit of a background in hardware, but I essentially got into CNC machining and milling with this machine about 8 months ago and really knew nothing before that. And it's just kind of amazing what you're able to do with when you combine like a good intuitive machine with the power of the web and the community, whether it's on YouTube or other places. So definitely this is meant to just be a starting point for you, and we can't wait to see what it is that you're going to do after this. And if anyone has any other questions, now's probably a good time, and I think our rooster has come together.
I think I got it. I mean, this is why in the cooking shows they have one turkey done, ready to go.
Push it in all the way, and
yeah, this is definitely better than a turkey. There's a rooster.
Does it stand?
That's probably my fault.
There we go.
I'll take the blame for that one.
No, it stands. It stands tall, small and mighty. All right, everyone. Thanks for joining us for this first ever Bantam Tools Skill School live stream class. More to come.